Find the open intervals where the function graph below is A, increasing, or B, decreasing. So a few things to remember here. Number one, when you're doing open intervals, that means the endpoints are not included. You'll be using parentheses on the ends of the intervals. Number two, when you're doing increasing and decreasing, you're using X values only. So domain values, not Y values, but X values. And the third thing is increasing means rising and decreasing means falling. So this function is rising starting at 5, and it actually, these are the Y values, but the X values where it's rising begin at 5 and go to positive infinity. So parentheses 5, infinity. For decreasing, this graph is decreasing. The Y values you can see are dropping here, but the X values are from negative infinity to 5. So the important things to remember here, again, parentheses for the open intervals, X values only, increasing means the graph is rising, and decreasing means the graph is falling. So this graph will increase, decrease, and then increase. Now we don't use a union between the intervals. We just put a comma. So it's increasing first. Again, we're looking at the Y values, but we want the X values for where the Y values are increasing. So negative infinity to negative 1. And then a comma between the intervals because it's increasing again, starting at this low point where X is 1, and then infinity. Positive infinity. Now, it's not going to go vertical because if it's a function, it can never be vertical. That would fail the vertical line test. So we know that it is eventually spreading out. Even though it's going up very rapidly, it's eventually going to spread out for all the X's all the way to infinity. Decreasing, there's only this one interval where it's decreasing. That starts at negative 1. And it decreases up into positive 1. And at positive 1, it begins to increase again. Number 3, suppose the graph is the graph of f prime of x. So this is the graph of the derivative. Okay? Now remember what the derivative tells you. F prime of x tells you how the original function is changing. It tells you the slope of tangents on the original function. So let's look at what's happening on our derivative. At negative 7, the derivative is 0. Left of negative 7, it's negative. Between negative 7 and negative 1, where it's at 0 again, it's positive. This is the derivative. And from negative 1 to infinity, it's negative. Now this tells you what's happening to the original function, what the slopes of the tangents are on the original function. So if the slope of the tangent is negative, you've got tangent lines going like this. and then it's reaching 0, and then it's turning around and it's positive until it gets to here, and then it's negative till it gets to here. So that's what the graph of the original function would look like if its derivative looks like this. So we're supposed to list the intervals on which the original function is increasing. So the original function is increasing only where the slopes of the tangent lines would be positive to the original function. That's between -7 and -1. So you got to be careful here, because if you just look at the graph, you're going to think increasing is to here and decreasing is to here, but that's the derivative. That's the slope of the tangent line. So they're asking you to refer back to the original function. What is the derivative telling you? List the intervals where the original function is decreasing. So here we have, on this side, we have tangent lines that are negative, have negative slopes, and again from here. So there's two intervals from -infinity to -7. And again from -1 to +infinity.